In this video, I'll walk you through the highlights of Chapter 6, how to work with data types, strings, and vectors. Recall that the assignment operator is the equal sign and that it copies the value on the right to the variable on the left. On this slide, the book demonstrates declaring the variable's data type and assigning a value to the variable all on one line. Notice the trailing F for floating point and the trailing L for long integer. Also notice there isn't a trailing letter after 1495 because the C++ language assumes a decimal point literal without a trailing letter to be a double. On this slide, note the comma operator, which supports multiple declarations and/or assignments on a single line. Pay special attention to the last line on the slide where the four variables A, B, C, and D are declared as integers on the line above, and here are assigned the value of 20 from right to left. What you are seeing now is a snippet from the C++ operator precedence chart I found at cppreference.com. I showed this chart in class and explained that each operator is assigned a precedence in relation to the other operators. This is a design choice made by the language designers, and compiler writers implement the language translation from human-readable source code to machine-readable object code according to the language designer's intent and specification. Not only do operators possess higher or lower precedence on the vertical plane, meaning certain operators are evaluated before others in the same code statement, but they possess associativity on the horizontal plane, meaning certain operators are evaluated from left to right or from right to left when appearing multiple times in the same code statement. So on the last line of the slide, D is assigned the literal value 20. Next, C receives a copy of the value assigned in variable D, and B receives a copy of the value that C now has, and A finally receives a copy of the value that B has. So that's a right to left associativity playing out. C++ has an auto keyword that I have not talked about in this class. Auto is part of the C language, but its meaning morphed a little, maybe a lot, with the introduction of C++. At this point in the semester, auto can be used instead of int, float, double, char, etc., causing the compiler to infer the data type of the variable name being declared. And it does it based on the type of the initializer value to the right of the assignment operator, aka the equal sign. And then brace initialization, that was new to C++ in C++11 back in 2011. We're up to C++20, but brace initialization can bite you if you don't know what you're doing. So since this is a beginning class, let's not worry about it for this class unless something absolutely requires it, and I can talk about it at that time if necessary. The const keyword is used to mark an identifier read-only. If we create an identifier with a data type, we call that a variable, and we can assign it a value and change its value during program execution. But when we mark an identifier as read-only, we're creating what's like a variable. It acts like a variable, works like a variable, but you can't change its value after initialization. The language translation machinery remembers this identifier as a constant and raises a compile time error if you try to alter its value later on in your program. This is yet another protection mechanism to keep bugs out of our programs. Finally, this slide demonstrates the const keyword declaring pi to be a constant of type double, which is initialized to an approximation of pi. The book in Chapter 6 has the code for this program. You can type it in and try it out. And if you try to update the value of pi after the initialization of the constant, you will get a compile time error. That's all for this first part of Chapter 6. I will create a follow-up lecture video for the balance of Chapter 6.